and graph them, and then find where they intersect on the XY plane. So that's one way to do it. We're going to practice all algebraic ways to solve them, but if you're in a pinch and you don't know what to do, you can always solve them by graphing. So the first method is substitution. What substitution is basically you're solving the equation for a variable and then going from there. So looking at your first problem, we've got 3y plus 4x equals 14, and then we have negative 2x plus y equals negative 3. What variable is the easiest variable to solve for? Yeah, we want to solve for this y value because all we have is y. We can get that one isolated the fastest. So when you're trying to determine what method to use when, look for the easiest one. So obviously, it's going to be very easy to solve for y first, which is why we're going to use what's called the substitution method. So the first thing I'm going to do is add the 2x. So when I add 2x to both sides, this moves. Y is alone. And you don't have to put it into slope-intercept form if you don't want to. If you're used to putting it in y equals mx plus b, you can do it that way, but it's not a requirement to solve the problem. So now that you have your variable isolated, what do we do with it now? Yeah, we're going to go to the first problem and plug it back in. That's why it's called substitution. So all you're doing from here is you are taking your first value, even though it's not numerical, and you're going to take it and plug it in to the first equation, or whichever equation you didn't manipulate. It will do you no good to plug it into the one you just solved. Like, there's no point. So we get 3, negative 3 plus 2x plus 4x equals 14. So we're just taking y out and putting y's equation in its place. Now, algebraically, these are not difficult problems. You're not going to deal with a lot of fractions. And normally, they're just really basic algebra problems. So the hardest part is just remembering the formula and making sure that you are using the correct method at the correct time. So I'm going to distribute. So 3 times negative 3, we get negative 9 plus 6x. And then we just bring everything else down because we didn't touch it. We didn't do anything with it, so there's no need to mess with it. You can combine as you go if you wanted to combine right here and write 10x, but I'm going to just save that for right here. So I get 10x, bring down the negative 9, equals 14. Add 9. Again, these problems are not very algebraically challenging. So we divide by 10. We get 2.3. It is completely up to you if you would like to write your answer as a fraction or if you want to write your answer as something different. Jasmine, that's okay. Thank you. So you can write as a fraction, you can leave it as 23 over 10, or you can leave it as 2.3. So now that we've solved for x, which equation should we plug into now? Yeah. So we can plug it into either equation that you want to. I personally would plug it in right here because y is already by itself, which is what we were trying to solve for anyway. So I'm going to take the x value and plug it into this equation. So it's called substitution because you isolate one variable, sub it in, get an answer, sub that answer into the other equation. It's basically like a big circle. So when we substitute, we get y equals negative 3 plus 2 times 2.3. And you can write your answer again as a fraction or as a decimal. It really just depends on the answer choices. So our y value here should be 8/5, or you can write 1.6. Your final answers will usually be written as coordinates because remember, these are lines that you can graph. So you're actually finding the intersection point of two lines. So all I'm going to do is write my final answer in terms of a coordinate. So I'm going to put my x value first, which is 2.3, and the y value second, which is 1.6. So this is your final answer as a coordinate. Depending on how the answer is shown in your answer options, that will dictate whether or not you need to write your answer as a parenthesis value or as individuals. Okay? But remember, we are actually finding a point. That is what systems are. They're intersections of lines. This one, this method, the substitution method, I think it takes a decent amount of time because you have to solve, then sub again, and then solve again. It can take just a little bit of more work. It will always work, but sometimes it's easier to not use substitution. So we're going to use next called elimination. So elimination is where you have two equations that you can eliminate variables from. So we have 2x plus 5y equals 17 and 6x minus 5y equals negative 9. A clue for elimination is that you have two variables that are the same with the same coefficient but opposite signs. So that lets you know you can immediately cross out a variable. So the way that you want to write these is you want to stack them on top of each other. So I'm going to take this equation and just put it on the bottom. 6x minus 5y equals negative 9. You just stack them up. Once you stack them, you just add top to the bottom. So you basically just add down. And put a little plus sign. Elimination just works top to bottom. Okay? The clue that elimination is the best way to solve the problem is your variable has the same coefficient but opposite signs. That means they will cancel immediately. So as we work this problem, we've got 2 plus 6, which is 8. So we have 8x. And then 5y minus 5y, they just go away. So I've eliminated my variable completely. 17 minus 9 is 8. So when we divide those sides by 8, x is 1. So you've already solved for your variable just by eliminating the y value. Yes, we could have used substitution if you wanted to by solving for a variable, but we would have dealt with some fractions, and that's not the fastest or easiest method. So once you have x by itself, you've got your value. You're going to take it, and I just will plug it in to the other equation. Okay. So I'm going to take x and just sub it in. We'll get 6 times 1 minus 5y equals negative 9. As you do these problems, you don't have to write 6 times 1. You can just write 6. But I don't want you to look back at your notes and not know where the 6 came from. So I'm going to have 6 minus 5y equals negative 9. And just solve for y. Subtract 6. Dividing by negative 5. Y's value is 30. You may or may not see your answer choices as separate entities. Remember, you could see x equals and y equals. But most of the time, you'll see them written as coordinates. So your coordinate answer would just be x, comma, or 1, comma. Since systems aren't really that challenging algebraically, the way that the ACT and the test that I give you will get you is the x and y value might be flipped. It might say 3, comma 1. That's not right because it's saying that the x value is 3 where the y is 1. So you just want to be careful of your answer choices, making sure that everything is kind of written the right way. So we've got substitution where we solve for a variable and then sub it in. We have elimination where we stack them up and cross one out. And then we have subtracting two equations. So the way that you would know that you would want to subtract equations is looking at your variables and noticing that you have a variable that has the same coefficient. So we've got negative 2x plus 15y equals negative 32, and negative 2x plus 5y equals negative 2. So we can see right here that we have potential for elimination. But I can't just cross these out because negative 4 plus, or negative 2 plus negative 2 is negative 4. So I can't just cross it out, which means I'm going to subtract the equations. So when I subtract them, You're basically just distributing the negative in. You're multiplying the second equation by -1. So over here, I'm going to rewrite -2x plus 15y equals -32. And then as I distribute the negative, negative times negative will be positive 2x minus 5y. And then I always write another negative over here because a lot of the times where you'll mess up is you'll forget to distribute the negative to every term. So if you kind of write it on the left and right, it's a lot easier to not make mistakes. Because again, the algebra is not challenging, but you'll make a tiny mistake and mess it up. So all we did was subtract the bottom, which changes every sign. Now you can add them together. The processes all kind of go together. You kind of need to use a combination of all of them on certain problems. But the one that's not combined with all the other ones is substitution. So substitution does not involve elimination or anything like that. So as we go through, adding top to bottom, -2x plus 2x goes away. 15y minus 5y is 10y equals -30. -32 plus 2 dividing by 10, y is -30. It's basically like elimination, but we manipulated the problem just a little. When you take the y value to substitute back into the equation, you have to substitute into an unaltered formula. So when I substitute -3 back in, I'm not going to use this altered equation that I multiplied by -1. You want to go back to the very original problem. So I'm going to just go to the top one. So I'm going to take this value and sub it in right here. Okay. Take the value, plug it in. But don't plug it into one that you messed with. So I'm never going to plug it into this one where I multiplied everything by a negative. It's going to change your answer. So I'll take this formula, I'll write it down here. As you can tell, systems are a lot of arrows to kind of follow your work because you're taking something from one place, plugging it in somewhere else. So we got -2x plus 15 times -3 equals -32. -2x minus 45. And where the algebra will get you is you'll make just a minor mistake. You might plug it into the wrong variable. You could miss a negative, which would definitely affect your answer. So you just want to be careful when you're doing these problems. So we should get x to equal -13 over 2. You could write it as a decimal if you really wanted. -6.5 would work. Completely up to you. It just depends really on what your answer choices look like. Okay. All right. So to finish my answer, write them as coordinates. So even though we solved for y first, it doesn't belong first in the parentheses. So the -13 over 2 has to go first, then your y value. So the way that you write your answer is not based on the order you solved it. It's based on how a coordinate is written. So it's always x, y. So I have to put my x value first, then my y. Okay. The last two methods are really similar. Method number 4 is multiplying one equation, and method number 5 is multiplying two equations. So they both involve multiplication, but then to solve them, you use elimination. So elimination is kind of the key to the rest of these methods. Substitution is the one that kind of stands alone. So on page 8, we'll finish up. We're going to practice by multiplying one equation. So in order to do a problem like this one, you want to look for similarities between the equations and multiples. So we've got 2x plus 2y equals 6, and 3x minus y equals 5. What you want to look for are one set of variables. So you pick x or y. You want to look for one of them being positive and one of them being negative. So looking at our problem, which variable should we solve for? We only want to multiply one equation. Which one? The bottom one? Okay, good. What variable are you going to try to get rid of? Yeah, we want to get rid of y. So in this problem, we see that we've got a negative y down here, a positive 2y up top. We only want to multiply one equation. So what should I multiply the bottom with in order to get my y's to cancel? Yeah, 2. The goal is to use elimination, but you have to manipulate your problem first. So I'm going to put a 2 over here and over here so I don't forget to distribute to everything. That's one of the most common mistakes is we just distribute to the left side. We have to make sure we distribute to the right side as well. Okay, so rewriting, we've got 2x plus 2y equals 6. 2 times 3 is 6. 2 times negative y is negative 2y. 2 times 5 is 10. So if you're trying to cancel y and you distribute and you don't get opposite coefficients, then you haven't multiplied by the correct number. So I want to get rid of y. So when I add down, 2 plus 6 is 8. 2y minus 2y is nothing. Equals 16. So x is 2. We're just manipulating the equation so we can eliminate a variable. Elimination is kind of the key to do all of these problems. Jasmine, yes, you could multiply the top by a half. There's a ton of different ways you could do it. Yeah, you can do it that way. So Jasmine typed online, could you multiply the top equation by 1/2? And the answer is yes. So you would just get x plus y equals 3, and then your y's would cancel there as well. So there's a couple different ways to do these. It just depends on how your mind sees it. But you should still get the same x value. All right, so x is 2. From here, remember, we're going to take this value and plug it into the original. You're not going to plug it into 6x minus 2y, the one that we multiplied. You always want to go back to the front. So I'm going to go to this top problem, and I'm going to substitute down here. It's a lot of arrows. Okay. The arrows should help you stay organized, I hope. Always substitute into the original. Now, if you wanted to substitute into the bottom, just ignore the 2's, and you can plug it in here. But don't plug it into one that you've manipulated. So 2 times 2 plus 2y equals 6. 4 plus 2y is 6. Okay. 2y is 2, and then you divide by 2. Y is 1. Remember, the algebra is not hard. It's just paying attention to your work. Making sure that you're putting the variables in the right spot. Making sure that you're properly eliminating variables and you're not just randomly crossing things out. To write our final answer, I'm going to put it as a coordinate. So 2 is first, then 1. So regardless of the equation that you multiplied by, whether or not you multiplied the top by a half or the bottom by 2, you should still get 2, 1 as your answer. So that's the good thing about systems. There's a bunch of pathways to solve them as long as the math is right. So for the very last one, this is where you could potentially multiply both equations. So all of these are options. You don't have to do them all. It's just an option. So we've got 3x plus 2y equals 1, and 4x plus 3y equals negative 2. To do a problem like this, I can't do a clear elimination. I can't do a very simple substitution. I'd be getting a lot of fractions. And I can't just multiply one of those equations. So what I'll have to do is multiply both of them by a number. The good thing about this is that the numbers are kind of in the equation already. You have to decide what variable you want to get rid of. So which one do we want to cancel? Okay, we can cancel y. So once you decide which variable to cancel, you only want to focus on those variables. The goal is to have them be the same coefficient, but opposite signs. So once you decide that you want to cancel y, only focus on y. What should we multiply y by? Yeah, we can do 3 on the top. And then on the bottom, we can do -2. A good way, if you have no idea what multiplies, what kind of multiples those go into, you can always just multiply them by each other. So this is a 3, I'm going to multiply the top by 3. This is a 2, I'm going to multiply the bottom by 2. Now, the reason we made the bottom negative is so that the variables will cancel when we add them together. They've got to cancel when you add them. So you could either make the top or the bottom negative. It's up to you. So then all you're going to do is distribute. So 3 times 3 is 9x. 3 times 2 is 6y. 1 times 3 is 3. Make sure that you distribute to everything. Put the variable or put the multiplying piece on the outside of both. So you remember to multiply everywhere. Then distributing. -8x. -6y. +4. As you do these, if you're trying to cancel the y's and you don't get +6 and -6 or a positive number with a negative number, then you know you didn't multiply right. So now you're just going to add, just like before. 9 minus 8 is 1, so x. Our y's go away. 3 plus 4 is 7. When you substitute the x value back in, make sure that you plug it into an original formula. Don't plug it into one that you've multiplied or manipulated. Always go back to the beginning. It's up to you if you want to do the top or bottom, but you always want to go back to the beginning. So I'm going to take my value, and I'm just going to plug it in, and I'm going to choose the top one. You can plug it into any. It doesn't matter. But always plug it into the original, not the one that you manipulated. So 3 times 7 is 21. Subtract your 21. 2y equals -20. So y is -2. From here, we're going to make sure that we are writing our answer as coordinates. 7, -10. The good thing about systems is that elimination usually works all the time. You just have to multiply or manipulate a problem. Substitution is the one that takes a little more effort, especially since you can get fractions, and dealing with a bunch of fractions can be time consuming. So it's up to you which method you use. But elimination is kind of the glue that holds all of these methods together, except substitution. That one's kind of on its own where you're solving. But elimination will work for all of these. Now, excuse me, if you're solving and your variables go away, that doesn't mean that you did it wrong, okay? It just means that you have 2 potential answers. It depends on what the problem looks like at the end. So if you're solving and your variables all disappear, if you have the same number on both sides, that's infinitely many solutions, meaning those lines are basically the same line. They don't actually cross. Okay, they're the same line. So if you have the same number on both sides, so whatever number equals the same number, it is infinitely many solutions. If the numbers don't match, then it's no solution. So it's kind of like when we were doing inequalities and your variables canceled. If your inequality was true, it was infinite. If it wasn't true, then it was no solution. Same idea. If your balanced on both sides of the equal sign, then it's infinite. If you're not balanced, then there's no solution. Okay? So we're going to practice. I'm going to hand out